A striking scene is beginning to unfold at the fuel farm near SpaceX's Starship Pad B, and it might just take you by surprise. Are we about to witness the debut of the first Starship tanker prototypes? Are you ready for a major turning point? Let's kick things off with a headline moment. Ship 36 has just completed cryo-proof testing at Massey's. This isn't your average test. It's a critical screening process where the rocket's liquid fuel tanks and pressure systems are pushed to their limits in ultra-cold conditions, simulating the harsh realities of space. Passing this test means Ship 36 has taken one solid step closer to reaching orbit. But do you know why cryogenic testing is such a big deal? In space, temperatures can plunge below 240 degrees Fahrenheit, causing metal to contract and crack if it's not engineered correctly. That's where SpaceX's advanced technology and ultra-durable materials come into play. Below ground, a maze of sub-zero pipelines. Overhead, thousands of satellites battling for position. This isn't science fiction. This is the real deal at Starbase and space. Now is taking you right into the heart of the tech storm. Just a few hours later, in the early hours of Tuesday morning, observers spotted Ship 36 being transported back to the megabay. Inside this massive assembly building, activity is buzzing. Ship 35, Ship 37, and even a new body in progress, Ship 38, are all present and accounted for. But one detail sparked questions across the community. Has Ship 35 vanished? In fact, SpaceX pulled a tactical switch. Ship 36 returned after completing cryo testing, while Ship 35 was swiftly rolled out to Massey's to prepare for the next stage, static fire testing. This is one of the most crucial and risky phases when the Raptor engines are fired up, while the ship remains locked firmly to the ground. And this is when all eyes turn to SpaceX. Have they finally resolved the issues that doomed the two previous Starship Block 2 prototypes? D2 prototypes. Can you guess what caused those prototypes to fail silently, without even making it to the main stage? It could have been a valve malfunction, unstable thrust, or even a software glitch. These incidents underscore the massive risks involved in pushing the boundaries of technology further than anyone ever has, but that's also what makes this modern space race so electrifying. Now, with Ship 35 about to fire up its Raptors for static fire testing, experts are cautiously optimistic. Could this be the moment that confirms SpaceX has identified and resolved its most pressing technical challenges? Starbase isn't just a launch pad. It's a proving ground for the future of humanity. Join Space now as we explore the dark side, the bright side, and the downright insane side of the space revolution. The focus of this test campaign is squarely on the engine cluster, the suspected culprit, behind the two catastrophic explosions during Starship's 7th and 8th flights. The big question remains unanswered. Was it the Raptor engines themselves that caused the RUDE's rapid, unscheduled disassembly, a technical term for blowing up? Or did the failure originate from supporting structural components? That mystery still lingers, but all eyes are now on Flight 9, a mission that could very well determine the future of the next-generation Starship. One thing has changed, and you're going to love this discovery. During the most recent rollout of Ship 36 to Massey's, photographer Jordan Guidry noticed something unusual. We can no longer peek at the Raptor engines. The engine bay, once left exposed for close-up views of each Raptor, is now sealed off with a brand-new metal shield covering everything. Why the change? Take a guess. One compelling theory is that this cover was installed to protect the engines from dust and debris kicked up from Highway 4, SpaceX's primary transport route. If true, this bolsters the theory that the issues in Flights 7 and 8 may have stemmed from engine contamination caused by foreign particles. What do you think? Could simple road dust really be enough to damage a multi-million-dollar rocket engine? Right now, everything hinges on Flight 9. But before that can happen, there's a major milestone ahead, the static fire test. If this test goes smoothly, Starship will be lifted onto the OLM orbital launch mount for a full wet dress rehearsal. So when might we witness the next historic Starship launch? I had previously predicted a time frame in the second half of May, but with Ship 35 already staged at the test site, that timeline could move up significantly. Now, about that strange test tank briefly spotted outside the Star Factory before it was quickly brought back in. What makes it so special? There's strong reason to believe it's the very first prototype for testing design concepts related to Booster Block 3, the upcoming evolution of Starship's massive booster stage. At Massey's, a brand new device called Can Crusher 2.0 is standing by to put that tank through hell. This highly anticipated campaign will mark the first physical step toward validating the architecture of next-gen Starship. Some sharp-eyed watchers even noticed large vent holes on top of Test Tank 17 and speculated, could this be an escape hatch for the lunar Starship's landing system? Unfortunately, the answer is no. These openings are actually for the pusher rod system inside Can Crusher 2.0, used to simulate external pressure from multiple angles during extreme load testing. Now let's head back to Pad B, where things are heating up. After weeks of focusing on the launch tower, the flame trench, and the OLM, it's time to explore an often overlooked but absolutely critical area, the propellant farm and fueling station. Don't blink, because what's happening at this tank farm might just be the wildest clue yet about the near future of Starship. Veteran engineers at SpaceX have learned some hard-earned lessons from Pad A. And there's one lesson they'll never forget: the concrete tornado. Remember that first launch from a pad paved with regular concrete? The result? A massive crater and tons of debris blasted in every direction, destroying much of the surrounding infrastructure. Who would have thought a single launch could unleash such a violent physical storm? The damage wasn't limited to the ground. The original vertical storage tanks were also wiped out in the hailstorm of debris. Not long after, those were replaced with horizontal bullet-shaped tanks, better known as bullet tanks, which are more structurally robust and less vulnerable to vertical shock loads. Since then, they've become the gold standard for all of SpaceX's fueling infrastructure. Only a few vertical tanks remain, and they're significantly smaller, strategically placed far from the launch pad's blast center. More importantly, those tanks don't store propellant. Some are used to hold nitrogen, and others aren't even tanks at all. They're recondensers designed to recover gas that boils off due to heat exposure, boil-off gas. You've definitely seen that thick white fog drifting across the dunes on launch day, right? It's mesmerizing. But here's the catch. Whenever that icy mist escapes the system, it means valuable gases are being lost forever, vented off into the atmosphere. That's exactly why recondensers are becoming a vital part of modern propellant handling systems. The pumping and storage infrastructure at Starbase is specially engineered to recover as much of these high-value cryogenic gases as possible. Instead of allowing vaporized gases to escape, the system routes them back into the recondensers, where they're cooled back into liquid form and pumped back into the main tanks. Not a single drop goes to waste. Now, take a look at the new pad construction site right next to Tower B. See those two massive rows of horizontal tanks. They're clearly divided into two groups, large and even larger. But here's the twist. They're all water tanks. Unlike the more minimalist approach taken at Pad A this time, SpaceX is going all in with a full-scale water deluge system. This system doesn't just help cool things down and protect the launch mount. It's absolutely essential for safeguarding the Starship booster itself. Interestingly, while the LOX liquid oxygen, methane, and nitrogen tanks are shared between both launch pads, the water tanks are not. Why? First, the irregular shape of the site makes connecting pipelines between the two pads extremely complex. Second, scale Pad B has a significantly larger water tank array than Pad A. From an aerial view, it becomes obvious why each pad needs its own dedicated system. But before we dive deeper into this zone, let me ask you something. Have you hit that subscribe button yet? And if you're like me and have ever dreamed of flying over Starbase in a helicopter at Space Now, we do that every week. And today, you're going to see things only SpaceX engineers typically get to see. As you can see, there are two main groups of tanks, 4 massive ones and 5 smaller but still quite large tanks. The standout feature here is the bright blue piping system running from the base of the tanks, curving upward, and then looping back down. This is a passive pressurization structure. Specifically, the system is engineered so that not a single drop of water can flow out or back into the tanks unless triggered by external pressure. That pressure comes from nitrogen gas stored in the vertical tanks standing nearby. It's a clever and highly efficient mechanism. Diagrams show that the water tank system is split into 2 independent halves each, with its own manifold leading to Weir's flow control structures, before channeling water into the flame trench. If you've ever seen that massive torrent of water flood the pad during a Starship countdown, this is where it starts. Pipes from the 4 large tanks branch out to feed water into both sides of the flame diverter system. Meanwhile, the 5 smaller tanks supply water to the deluge spray system mounted directly above the launch platform. So, how does it all work? Nitrogen is compressed through the manifold, creating high pressure that forces water out of the tanks through the blue piping network and into the powerful spray system. Looking at the sheer size of this hardware, you can feel the true scale of the entire setup. And keep in mind, this is just the water system. We're only getting started. Launching a rocket takes a lot more, namely propellant. For Starship, that means 2 primary cryogenic fuels, methane, CH4, and liquid oxygen, LOX. The main propellant tank farm is strategically located between the 2 pads, making it easy to share resources. But it's not just about storage. SpaceX is building a completely custom system of valves and pumps designed for both fueling and defueling operations. There are 9 pump units lined up side by side. Some are still missing motors or their primary pumping mechanisms, but their structure is complete enough for analysis. And here's a detail that sounds simple but is actually quite significant. 5 of the pumps are designated for the Super Heavy booster, and the remaining 4 serve the Starship upper stage. Do you notice anything strange? The booster needs twice as much fuel as the Starship, so why split the pumps? 5 and 4. Why not 6 and 3 for a more logical distribution? This isn't a design oversight. It's a glimpse into SpaceX's future vision. Have you figured it out yet? Just 5 pumps for the booster and 4 for the Starship. Why split them that way when the booster consumes twice the fuel? The answer is tankers, and Space Now is here to show you why this one detail could shape the future of lunar and Mars missions. Most likely, SpaceX is preparing for the Starship tanker variant, a fuel transport version designed to deliver propellant into space. The tanker will feature a much larger internal tank than the standard orbital Starship. This capability is absolutely vital for missions to the Moon, Mars, and beyond. NASA's Artemis 3rd mission depends on the Starship HLS human landing system. Without tankers, there's no way to refuel HLS in orbit, which means no moon landing. It's that critical. So the big question: how soon will we see the first tanker prototype? What's your guess? How many months? Drop your prediction in the comments. I'm betting we'll see something within 3 months. The first clues will show up in the nose cone area. Look out for unusual nose sections appearing behind the windows of the Star Factory. We'll need at least 2 prototypes, one dedicated tanker and another Starship modified for orbital refueling operations. If you're passionate about aerospace or military engineering, this is the phase you absolutely don't want to miss. Starship tankers will have distinct features, specialized docking hardware, and of course much larger fuel tanks. These orbital freighters will carry propellant into space to supply the future Starship depot, a separate Starship variant that SpaceX will also need to roll out soon. Back to the pump system. When tankers start rolling off the production line, splitting the pumps into a 5-4 configuration makes perfect sense. One group will handle the massive fuel flow for super heavy boosters. The other group will support multiple Starship configurations from crewed missions to fuel transfer operations. We're entering the true operational era of Starship, not just test flights anymore. The Florida launch site on the Space Coast is expected to handle commercial missions, while Starbase in Texas will remain the giant laboratory for continuous innovation. Isn't it fascinating how just looking at an unfinished set of pumps can already reveal so much about SpaceX's strategic roadmap? Directly beneath the massive water tanks is a technical trench, housing the hidden maze of pipelines that deliver propellant and industrial gases. Although most of it is now sealed, you can still spot 2 exposed expansion joints. These special angled pipe sections are engineered to absorb volume changes in the system. As temperatures swing from freezing cold to scorching hot, metal can expand and contract by several millimeters. This is how engineers conquer the laws of physics to build a fueling station for spacecraft. And you know what's even cooler than temperature changes? A change in perspective. What could be better than seeing the entire Starbase complex from above by helicopter? Now, let's shift to a different sky kuiper. Amazon's satellite internet project just hit a major milestone. Last week, the first 27 satellites of the Kuiper constellation were successfully launched aboard a United Launch Alliance Atlas Vi-55V1 rocket. Sounds promising, right? But to fully deploy its planned 326 satellites, Amazon faces a massive challenge. They must get at least half, around 1/600 satellites, into orbit by July 2026, or risk losing their license from the Federal Communications Commission, FCC. Doing the math, that means Amazon would need to launch about 27 satellites every week. Sound like science fiction? Actually, not really, because SpaceX is already doing it. That's right. While Amazon is just getting started, SpaceX has already launched its 250th Starlink batch, bringing its active satellite count to over 7,200. If this were a 100-lap race, SpaceX would be nearing the finish line, while Amazon is just revving its engine. Catching up at this point seems nearly impossible. Still, Amazon needs to accelerate if it hopes to get an extension from the FCC. Here's the catch: right now, only SpaceX has the launch cadence and capability needed for that kind of rapid deployment. But with the fierce rivalry between Jeff Bezos and Elon Musk, Amazon hitching a ride with SpaceX is practically off the table. Take a second to let this sink in. There are about 12,000 active satellites currently orbiting Earth, and over 7,000 of them belong to Starlink. Experts predict that by 2030 that number could reach $60,000. Can you imagine? We're heading into an era where the sky is no longer empty. So what's going to keep things in balance? Advanced space, debris removal tech, maybe. Here's some good news for Blue Origin. On April 24th, they completed a 15-second static fire test of the New Glenn upper stage, powered by the BE-3U engine, an upgraded version of the BE-3PM used on New Shepard. Each engine now delivers up to 175,000 pounds of thrust, 778 kilonewtons, significantly boosting payload capacity, a major step forward for Blue Origin. But the question remains, can they move fast enough to catch up in a space race that's accelerating at breakneck speed? And that's a wrap for today. Is there something in the vast universe you'd like us to decode? Drop a comment below. Space Now is always here to bring you the story behind every rocket and every star. Don't forget to hit follow so you never miss the next video.